In this video, we will talk about link aggregation. Link aggregation in Cisco networking is a technique that combines multiple physical network connections into a single logical connection. This enhances the bandwidth, provides redundancy, and improves the network performance. Okay, so by aggregating multiple links, the total bandwidth available between devices can be increased. For example, if you go ahead and combine 4 1 gigabit per second links, the result in an effective bandwidth of up to 4 gigabit per second. So if one of the links in the aggregation fails, traffic continues to flow over the remaining links that will ensure the network availability and the reliability. And also link aggregation can distribute the traffic across the combined links based on multiple criteria such as MAC address or IP addresses, which optimizes the performance. So we have some significant benefits of using link aggregation. Okay, first of all, you just configure one port channel interface instead of configuring 4 separate links. Okay, as you could see on the screen, there are 4 different physical interfaces for both switch 1 and switch 2. You need to configure each and every physical link separately if you are not using an Etherchannel. But with Etherchannel, you can just go ahead and configure only one PO link, port channel link, instead of configuring 4 separate links. Secondly, an Etherchannel is just one logical link for spanning tree protocol. Okay, so for example, any of the interface in this Etherchannel, if it goes down, for example, let's say gig 101 went down, spanning tree recalculation is not made again. Okay, that is just one link for the spanning tree protocol. Okay, so spanning tree is not really a concern if you are using the link aggregation. So third, we can make load balancing between separate links, as I told you before. And lastly, we can provide higher bandwidth up to 8 gigabit per second by combining different speed of the physical interfaces. We are using 2 main protocols while we are creating Etherchannel, and they are PAGP and the LACP. PAGP is a Cisco proprietary protocol used to automate the creation and management of link aggregation, specifically for Etherchannel configurations. So it automatically detects and configures multiple Ethernet links between switches or routers to form a single logical Etherchannel. So PAGP uses a negotiation process between the connected devices to determine which ports can be bundled together based on their capabilities and configurations. When you are configuring the PAGP, there are 3 channel modes. Okay, so the first mode is the auto mode. Auto mode configured switch will passively wait for a PAGP negotiation from another port in desirable mode. The desirable mode actively tries to negotiate with other PAGP enabled ports to form an Etherchannel. On the other hand, on refers to no protocols are used. It assumes the other side has enabled the link aggregation. So if you see the chart on the right of the screen, that will show you in which modes you will be establishing an PAGP. Okay, so if you are using channel mode auto on one switch and channel mode auto on the other switch side as well, you will end up not to be configuring a successful PAGP. On the other hand, for example, if you use auto with desirable, you will end up with a successful PAGP. So you can match the modes together as per the chart, and you can see when you will be establishing this PAGP. So on the other hand, LACP, that is the IEEE specification, which is used for creating Etherchannel and can be configured to operate in 3 different modes. Okay, so on mode activated ports is the channel member without protocol. Active mode enabled ports, active means these ports actively sends LACP packets to negotiate with the other device to form a link aggregation. Passive means, on the other hand, that is responding to LACP packets from an active device to form the aggregation. So again, let's have a look to the chart. For example, if you have active configuration on both ends, you will end up with a successful LACP. As well, if you have the active passive configuration, active one side and passive on another side, you will end up with a successful LACP again. So it is a good practice to memorize this chart and understanding when the LACP is being successfully established. To configure Etherchannel, guys, firstly we need to check if our switch supports Etherchannel or not. That is the first step. Secondly, we need to make sure that duplex modes, port speeds, and the VLAN information, those 3 information must match on ports at the both sides. And lastly, of course, we need to choose the right channel. Okay, so for example, if this is a gigabit Ethernet port, on the other hand, if this is a fast Ethernet port and you are connecting this together and trying to establish an Etherchannel, that won't work, okay? Or if this is a full duplex and on the other hand, other side is half duplex, it will fail again. Same applies to the VLAN IDs. If this port is belonging to VLAN 20, on the other hand, other port is VLAN 30, then it will fail to establish the Etherchannel once again. So here the configuration and how it looks like. So in both switches, what you are doing, you are configuring both interfaces, both Fast Ethernet 01 as well as Fast Ethernet 02. The easy way to configure both interfaces in one shot is doing the configuration with the range command. Interface range Fast Ethernet 01-2. That means this configuration will apply both Fast Ethernet 01 and Fast Ethernet 02. And I'm going ahead and applying my trunk configuration, switch port mode trunk. And lastly, I'm defining my channel mode. Okay, channel group 1 mode active. On the other hand, with switch 2, I need to pick a channel mode where helps me to establish the LACP as you saw in the chart. So for example, if I go ahead and type passive in here, that will be enough to form an Etherchannel configuration. So how I am verifying the Etherchannel configuration? The command is show Etherchannel summary. Okay, so you should be able to see the port channel as well as the SU. SU means layer, this is a layer 2 Etherchannel and in use. And you will be able to see the protocol used with this Etherchannel, which is LACP in this case, and you will be able to see the ports in the Etherchannel, which are Fast Ethernet 01 and Fast Ethernet 02. So we are coming the end of this session also, and thank you so much for listening to me.